I'm Mark Woodward. My PhD is in computer science, not biology, focusing on machine learning and so AI in general. Most recently, I was at Google Brain, which is Google's sort of deep learning neural network research lab, which has since merged with DeepMind. And at that point, a couple of years ago, I just made the realization that I wanted to apply AI to something that I thought mattered more than what I was working on. Cryonics was that focus for me. So yeah, so I founded this company. Okay, so these two little cuties are Lydia and Timothy. They were frozen for 30 years. I'll sit down, is that better? Yeah. So they were frozen for 30 years. They were conceived in 1992. They were cryopreserved at that time. And then in 2022, they were thawed and implanted, and now they're healthy toddlers. Okay, so that's just amazing on the surface, but it also really demonstrates that low temperature does halt biology, so for at least 30 years. Okay, and we'll pause on that for a second. So talk about death a little bit. So I know you're all well aware of this, but that 60 million people die every year. That's, large multiples of things that we think of as huge tragedies like the World Trade Center. So it's that 60 of those are happening every day. That's how many people are dying every day. I think for most of us, when we see a figure like that, or we think about death, we think it's old people. They've lived a full life. They're happy. They're okay. They've come to accept that they're going to die. Unfortunately, that's just not supported by the literature. So it turns out among hospice patients who have weeks or even days of living, it still is that 83% of them would like to continue living. They still want to go on. And these are people that are in the last days of their lives and they want to go on. So this is a big problem. A lot of the technologies you all are working on will help address this. Those technologies will roll out in phases. So deaths will still be a problem. Also, even once we've solved, the major causes of death, there still will be those that slip through the crack, and we would like to, if those people would like to be preserved, we would like to be able to preserve them. So there still is a need for some preservation. Okay, so what's the challenge? Why can't we, what Lydia and Timothy did, why aren't we just able to scale that up? So the problem is humans are really large. So from the phase that Lydia and Timothy were preserved at to humans, that's 4 orders of magnitude. So it's much larger. But, so what? What's the problem with being larger? Well, the problem, and we can talk about this later, the physics, it's not that complicated, and I think it's pretty interesting, but too much for this talk, that basically thicker tissue has slower heat transfer. This is the same reason why, you want thicker insulation in your walls. That heat transfer into your home or out of your home will be slower. So slower heat transfer. And that means that ice, you spend more time in a region where ice can form, and ice really is the enemy of this preservation. So more ice can form, and in order to combat that, that means you have to increase the concentrations of the chemicals that avoid the ice being formed. So you need higher concentrations of these chemicals, and unfortunately, at those higher concentrations, they end up being toxic. So you're faced with this, the thing you're adding to avoid the ice and preserve the tissue or the organism ends up killing it because it's toxic. Okay, so that's the problem. Wake Bio, this is my company. We formed in January. We are focusing on organisms. We're working up one organism at a time, starting with zebrafish. And the goal is to preserve the adult phase of that organism. We use AI, because of my background, to identify cryoprotectants, so new chemicals that are less toxic, but also to optimize. There's a lot of other dimensions of the preservation. So what is the cooling rate? Are there phases of sort of annealing you need to have? There are reasons you might want to do that. So we're optimizing all of the parameters and attempting to discover, appropriate cocktails and new chemicals that will make this possible. We use AI and this rapid experimentation in a tight loop. So we'll do an experiment. The results of those experiments are fed and update the machine learning model, which is used to then predicts the next experiments to run, and that keeps going. So that's pretty much it. So yeah, Wake Bio, I mean, we are still raising. there is a little bit left in our pre-seed round. So we just formed in January, but we've gotten started with all this technology. So if you know anybody who might be an investor that would love to talk to them, we're also interested in talking with organic chemists and people like that who could help out with using a human brain to augment some of the AI and propose different directions. So wake.bio, and you can reach me. I think my email's on there, but whatever, it's mark@wake.bio.
Awesome. Thank you very much, Mark. So folks, Mark was very concise, and so we have time for perhaps a question, maybe even two. Anybody have any questions about cryo and AI? All right, here we go.
More of just a kind of a higher level one, but in comparison to the other longevity treatments that people are trying to accelerate with AI, maybe you can talk a little bit about why your preference is towards cryo.
Well, I'm not very familiar with all the work that you're doing. It's certainly reading Aubrey's book motivated this for me, thinking that, this doesn't do any good without all the wonderful treatments that you're working on. Like, so what, you wake up and you're facing the same disease that you were preserved at. I think it's more just, my motivation is more just my personality. It's like, well, we need the safety net. Like, all this wonderful money is going in development on longevity, but we need that safety net for, and I know I think it might be Aubrey that doesn't like that term, thinking of it as a safety net, but I don't know. We need that's my motivation. You're fine with that one? All right, cool.
All right, folks. Thank you very much. Give it up for Mark Woodward.